Hello everybody, welcome back. In this short video, we're going to look at what a negative lens can do in terms of image formation, because we've been talking about positive lenses and all the great things they can do. But now we have to look at the negative lens. There is actually an application of a single negative lens we'll talk about in the next video. I think I mentioned it already, where you can correct vision for people that can't see things far away. A negative lens can help them. So let's look at what a negative lens ray trace would look like. Okay, so whoops, let me call up the PowerPoint. This is the same PowerPoint presentation. Okay, this is the last slide, I think, on it. So virtual image formation by negative lens, and I'm just going to go ahead and state a negative lens can only form a virtual image, and that is true. Now we've seen a positive lens capable of forming real images, like in a camera or projector, or a virtual image, like in the simple magnifier or magnifying glass. So a positive lens by itself can form either a real image or virtual image depending on where the object is. Object outside the focal point, real image. Object inside the focal point, virtual. A negative lens can only do a virtual image. So let's do a typical ray trace. Here is a generic negative lens. I've indicated the two focal points. Here's my object. There's my first ray. Now, let's be careful, it's a negative lens. So where does this ray go? Well, it diverges, right, as if it came from that front or left focal point. So it's going to do something like that. Any ray parallel to the optic axis is going to diverge as if it came from this front focal point. The second ray that we draw is our favorite ray. It goes straight through the middle. There it is. Now, the two rays that are leaving are this orange ray here going up to the right and this purple ray going down to the right. They are definitely diverging. So we trace them backwards. You can see I've traced the orange ray back here with that dashed line. The purple ray that exits, trace it back. That's just the way it came in for the incident ray came in. So I'm going like this, tracing right back there. And look, those two trace backs appear to, they do intersect right at that point. That's the tip of our image. So we can just fill it in. Boom, there it is. All right, how would you characterize that image? Real or virtual? It's virtual, diverging rays. Yeah. It looks to me like it's smaller than the object. Yep. And what else? Oh, it's not inverted. Now, to see this, you are going to have to catch some of these rays that are diverging as they leave the lens. So your eye's going to have to be over here to catch those rays. And again, the cornea and lens in your eye will take the diverging rays and converge them onto your retina and form a real image, but your brain's going to think it's looking at this green image right there. Okay? Now, the thin lens equation still works. Lateral magnification still works. Okay? Although you'd really be more interested, well, nobody wants to make a magnifier like this because it won't magnify. So nobody really cares about the angular magnification in this case. But you can still use the thin lens equation, and if you want the lateral magnification. All right, so there's P, there's Q. Note the Q will be negative from the lens to the image, and then, of course, H and H prime. Okay. Now, you might ask, well, what if we bring the object closer? In particular, what if we bring it inside that front focal point? Because then, right, for the positive lens, the type of image we got changed. Well, it turns out you're still going to get a virtual image. Let's do the ray trace. Or better yet, stop the video and you try the ray trace with that second configuration. Did you do it? Okay, here's the first ray. That's going to diverge as if it came from the front focal point. The second ray goes right through the middle of the lens. Trace the diverging rays back, and they intersect right there. There is the image. See, we're still getting a virtual image in between the object and the lens. Now, I will say, as you move the object closer, you're always going to get the virtual image in between the object and the lens. It will get larger. Its lateral dimension, the H prime, will get bigger as you bring this object closer and closer. But you're always going to get a virtual image. Okay? Again, there is an application for a negative lens. We'll talk about that in the next video where we talk about the eye and some simple solutions to correct some common vision problems. Okay, that's it. Short video. Bye-bye. Oh, I forgot to label P and Q there. See? P right there, Q right there. Okay, now I can say bye-bye.